In today's urgent cybersecurity briefing, we need to talk about a critical Linux warning that has sent shockwaves through the global tech community. Over 800,000 devices running Linux are currently exposed to the internet, vulnerable to attack, and in many cases, completely unprotected. This isn't hype. This isn't clickbait. This is a real and ongoing security crisis affecting individuals, businesses, data centers, IoT networks, and even critical infrastructure. If you run Linux on a server, a virtual machine, a home lab, a cloud instance, or even a smart device, you need to pay close attention to what's happening right now. Linux powers the backbone of the internet. From web servers and cloud environments to embedded systems and industrial controllers, Linux dominates global infrastructure. Distributions like Ubuntu, Debian, CentOS, Red Hat, Enterprise Linux, and Alma Linux are trusted worldwide because of their stability, flexibility, and open source nature. But that same openness, combined with misconfiguration, delayed patching, and exposed services, has created a massive attack surface. According to recent internet-wide scans conducted by security researchers using tools similar to Shodan-style indexing platforms, more than 800,000 Linux-based systems are directly accessible from the public internet with vulnerable services exposed. Let's break down what exposed actually means. An exposed device isn't necessarily hacked yet. It means that a service on that device is reachable from the internet and is either unpatched, weakly authenticated, or running outdated software with known vulnerabilities. Attackers don't need to break in with sophisticated zero-day exploits. If administrators leave SSH open with weak credentials, run outdated kernels, or expose administrative dashboards without firewalls. In many cases, attackers use automated scanning bots that probe millions of IP addresses daily, looking for exactly these weaknesses. One of the biggest concerns in this wave of exposure involves Secure Shell, or SSH. SSH is essential for remote Linux management, but when configured improperly, it becomes a prime target. Many systems still allow password-based authentication instead of key-based access. Some use default usernames like root or admin. Others fail to change default credentials on embedded Linux systems. Brute force attacks against SSH happen constantly, with bots attempting thousands of login combinations per minute. Once access is gained, attackers can install backdoors, cryptominers, or ransomware payloads. Another significant issue involves outdated kernels. The Linux kernel is the core of the operating system, and vulnerabilities at that level can allow privilege escalation or remote code execution. Over the years, critical flaws such as dirty cow, dirty pipe, and other kernel privilege escalation vulnerabilities have demonstrated how powerful kernel exploits can be. Systems that fail to apply updates remain vulnerable long after patches are available. In enterprise environments, patching delays are sometimes caused by fear of downtime, compatibility concerns, or operational complexity. But those delays come at a cost. The rise of containerization and cloud deployments has also contributed to this exposure. Platforms like Docker and Kubernetes often run on Linux hosts. When administrators misconfigure container runtimes or expose management interfaces to the public internet, they unintentionally provide attackers with powerful entry points. In some documented cases, attackers have discovered open Docker APIs, deployed malicious containers, and used compromised infrastructure to mine cryptocurrency at scale. Cloud misconfigurations, especially in environments hosted on providers like Amazon Web Services, Microsoft, Azure, and Google Cloud Platform, amplify the problem because improperly secured instances can be spun up and forgotten within minutes. IoT devices represent another massive portion of the 800,000 exposed systems. Many routers, cameras, NAS devices, and industrial controllers run lightweight Linux distributions. Manufacturers often ship devices with outdated kernels and rarely provide long-term updates. Even when updates are available, users frequently fail to install them. The result is a global network of Linux-powered devices with open ports, default passwords, and vulnerable services. Botnets like Mirai demonstrated years ago how quickly attackers can weaponize insecure IoT devices. While Mirai specifically targeted embedded Linux systems, newer botnets have evolved, scanning continuously for new victims. The threat landscape has grown more aggressive. Ransomware operators now actively target Linux servers, not just Windows environments. Groups such as LockBit and BlackCat have developed Linux variants of their malware to target enterprise servers and virtualization hosts. Once attackers gain access to an exposed Linux system, they can encrypt critical data, exfiltrate sensitive information, and demand multi-million-dollar payments. In cloud-native environments, compromising a single misconfigured server can provide lateral movement into entire clusters. One particularly alarming aspect of this exposure crisis is that many system owners are unaware their devices are publicly accessible. Network address translation, port forwarding, and misconfigured firewalls often create unintentional exposure. A developer might temporarily open a port for testing and forget to close it. An organization might deploy a staging server without implementing proper access controls. Over time, these small oversights accumulate into a massive pool of vulnerable endpoints. Automated scanning engines make this worse. Attackers use high-speed scanning frameworks that can map the entire IPv for space in minutes. They identified open ports, fingerprint service versions, and cross-reference them against vulnerability data. If a server is running an outdated version of OpenSSH, Apache, and Jinx, or a vulnerable database service, it becomes a candidate for exploitation. The process is automated, relentless, and global. Databases are another major concern. Exposed instances of MySQL, PostgreSQL, MongoDB, and Redis have repeatedly been found accessible without authentication. In some cases, attackers don't even need to exploit a vulnerability. They simply connect and access the data. There have been numerous incidents where sensitive customer data, internal logs, or intellectual property were exposed because a database port was left open. Linux servers frequently host these databases, making them prime targets when Another layer of risk involves outdated web applications running on Linux stacks. A typical LAMP stack, Linux, Apache, Miski, PHP, remains widely used. If the web application layer contains vulnerabilities such as SQL injection, command injection, or file upload flaws, attackers can gain a foothold and then escalate privileges on the underlying Linux system. Even if the kernel is patched, poor application security can compromise the entire server. The 800,000 device figure also includes systems vulnerable to known critical CVEs that have publicly available exploit code. When exploit code is published, attackers integrate it into their automated toolkits almost immediately. That dramatically shortens the window between vulnerability disclosure and widespread exploitation. Security teams call this the patch gap, and it's a race against time. If administrators delay updates, attackers often win. Remote management panels are another soft target. Tools like Webman, cPanel, and other administrative dashboards are sometimes exposed directly to the internet. Without multi-factor authentication and strict firewall rules, these interfaces can become gateways for attackers. Even strong passwords may not be enough if software vulnerabilities allow bypasses. Cryptojacking has surged alongside ransomware. Instead of encrypting data, some attackers quietly install cryptocurrency mining software on exposed Linux machines. Because servers often have high CPU capacity and run continuously, they are ideal for mining operations. Victims may only notice performance degradation or increased cloud bills. By the time the activity is detected, attackers may have generated significant profit, supply chain risk compounds, everything. If an organization relies on third-party software repositories or container images without proper verification, they may inadvertently deploy compromised packages. The open source ecosystem is powerful but requires vigilance. A single malicious dependency introduced into a widely used package can ripple across thousands of systems. The geographic distribution of exposed devices spans the globe. Systems are located in North America, Europe, Asia, South America, and Africa. This is not a localized issue. It's a systemic global challenge rooted in how infrastructure is deployed and maintained. Small businesses are particularly vulnerable because they often lack dedicated security teams. However, even large enterprises fall victim due to complexity and scale. So, what can be done? First, organizations must conduct external attack surface assessments. That means scanning their own IP ranges to identify exposed services. Tools that simulate attacker reconnaissance can reveal open ports and outdated software. Second, SSH should be hardened immediately. Disable password authentication, enforce key-based logins, change default ports if appropriate, and implement rate limiting or intrusion prevention systems. Third, patch management must become a priority. Regular kernel and package updates are essential. Modern Linux distributions provide automated update mechanisms. While reboots may be required for kernel updates, solutions such as live patching exist for enterprise environments. Fourth, firewalls should default to denial inbound traffic except explicitly required services. Services intended for internal use should never be publicly accessible. Multi-factor authentication should be implemented wherever possible, particularly for administrative interfaces. Logging and monitoring must be enabled to detect unusual login attempts or privilege escalations. Centralized log aggregation helps identify patterns that might otherwise go unnoticed. For IoT devices, Users should change default passwords immediately and check for firmware updates. If a device no longer receives security updates from the manufacturer, it may be safer to replace it. Network segmentation can prevent compromised IoT devices from accessing critical systems. In cloud environments, security groups and access control lists must be carefully reviewed. Instances should not have public IP addresses unless absolutely necessary. Identity and access management policies should follow the principle of least privilege. Education also plays a crucial role. Many exposures occur because administrators underestimate risk or assume obscurity provides protection. Attackers don't need to know your server exists in advance. Automated scanners will find it. The 800,000 exposed devices represent more than a statistic. They represent potential entry points into businesses, hospitals, research institutions, and government systems. Each vulnerable server is an opportunity for exploitation, and the number could grow if proactive steps are not taken. This is not about fear, it's about awareness and action. Linux remains one of the most secure and robust operating systems in the world when properly configured and maintained. Its open source model allows rapid patching and transparency. But security is not automatic. It requires deliberate configuration, continuous monitoring, and disciplined maintenance. Right now, somewhere in the world, automated bots are scanning IP ranges, probing ports, testing credentials, and searching for the next unpatched Linux system. The question is not whether scanning is happening. It is whether your systems are prepared. If you are responsible for Linux infrastructure, take this warning seriously. Audit your servers, close unnecessary ports, apply updates, implement strong authentication, monitor logs. The cost of prevention is far lower than the cost of incident response. The exposure of 800,000 Linux devices is a wake-up call. It highlights how interconnected and interdependent our digital world has become. One misconfigured server can become part of a botnet. One outdated kernel can become an attacker's foothold. One exposed database can leak millions of records. Security is not a one-time setup. It is an ongoing process. And in a landscape where threats evolve daily, complacency is the greatest vulnerability of all.